If you were told that keys to a new car were buried 50 meters away from where you stood, and that the first person to find them would get to keep the car, would you be able to find the keys easily? It would be difficult to find the keys because you were just given how far the keys were from you. You weren't given the direction you should travel. Physical quantities fit into two categories, vectors and scalars. Vectors are quantities that need a magnitude or size and a direction to fully describe them. Scalars just have a magnitude. To fully describe where the car keys discussed earlier were, we would need the magnitude, 50 meters, and a direction, such as north. In previous lessons, we've already discussed several quantities that are vectors and scalars. For example, when we discussed distance and displacement, remember displacement needed a direction, which means it is a vector quantity, while distance did not need a direction, so it is a scalar. Likewise, velocity is a vector and speed is a scalar. Another vector quantity we've discussed is acceleration because it has a direction. More scalar quantities include mass and temperature because they don't have directions. A vector is often drawn as an arrow because the length of an arrow can describe the magnitude of the vector and the arrowhead shows its direction. The arrowhead is often called the head or the tip of the vector. The back of the arrow is often called the tail. Let's try drawing a few vectors using a scaled drawing. If we wanted to draw a vector to represent where the keys were located, we wouldn't want to draw a vector that was 50 meters long because it wouldn't fit on our paper. So we'd choose a scale, maybe 1 centimeter equals 10 meters. This means every centimeter on our drawing would really represent 10 meters. So we would draw an arrow that was 5 centimeters long, which would represent the 50-meter long displacement. And we would draw it in the correct direction, which is north. The drawing should have a scale listed, the magnitude and direction clearly shown on the picture, and the arrow should have a clear head and tail. There are two common conventions for describing the directions of vectors. The first is using north, south, east, and west. If a vector is not just in a cardinal direction, we tell how far we've rotated from a cardinal direction. For example, if a direction was 20 degrees south of west, that means we started from west and then rotated 20 degrees south from west. So you can think of the of in a direction like south of west like it's saying from. So 20 degrees south of west is 20 degrees south from where west is. What about if the direction was 30 degrees north of east? That means start at the east and rotate 30 degrees north from east. Let's try 50 degrees west of north. So we'd start at north and rotate 50 degrees west from north. A particular vector could be described with two different directions. For example, the last vector we did could also be described as 40 degrees north of west, because starting at west and rotating 40 degrees north gets you to the same place as starting at north and rotating 50 degrees west. If you're given a direction like southeast or just SE, that means it's exactly halfway between south and east, so it would be at an angle of 45 degrees from either direction. The other common convention is the way you usually describe directions in math classes, rotating from the positive x-axis, so this vector would be at 50 degrees, while this one would be 100 degrees, and this one would be 320 degrees. If given north, south, east, or west information, east corresponds with the positive x-axis, so the 320 degrees could be said as 320 degrees counterclockwise from east. In summary, vectors are quantities that need both a magnitude and a direction, while scalars need a magnitude only. Vectors can be represented using a scaled drawing of an arrow which has a head and a tail. The magnitude of the vector is represented by the length of the arrow, and the direction is shown by the arrowhead.